Hi everyone, we're going to do some review here. This is question 17 from the Developmental Combined and Developmental 2 final exam. The question says, determine the slope of the line represented by this equation. Negative 10x plus 2y equals negative 18. So to determine the slope from an equation, the equation has to be solved for y so that we can see this y equals mx plus b. So we're going to take this equation, negative 10x plus 2y, and we're going to solve for y, which means we're just going to isolate y to one side of the equation. First, we need to add the x term to both sides. We're going to add 10x to both sides. That's going to make this term cancel. We'll have 2y equals 10x minus 18. To isolate this y now, we need to get rid of this 2. So to undo multiply, we divide. Make sure you divide both the terms on the right side individually by 2. This cancels, and we have y equals. Alright, this reduces. 10 divided by 2 makes 5x minus, and 18 divided by 2 makes 9. So now we have our equation in the form of y equals mx plus b. So m, or the slope, when an equation is solved for y, the slope is the coefficient in front of x, so that would be 5. Alright, question 18 says, identify the graph represented by this table. So this table is just giving you, in table form, ordered pairs. So this is an ordered pair. These are 5 individual ordered pairs for the lines, one of these lines that's graphed, A, B, C, D. So I'm going to look at this first ordered pair, which would be negative 2, 0. I'm going to look on these graphs and see which graph has a point that crosses negative 2, 0. So when I look at this first graph, I go negative 2x and 0y would be right here, and obviously the line doesn't go through that point, so it can't be this graph. When I look here at negative 2, 0, that's right here, and this line does cross at negative 2, 0, so it could be this one, so I'm going to circle that. When I look at negative 2, 0 here, this line doesn't go through that point, so it can't be this graph. When I look at negative 2, 0, this line does go through, so it needs to be one of these graphs. So I'm going to go to the next ordered pair, which is negative 1, 0.5, which is 1/2, also 1/2. And I'm going to look at just these two graphs that I circled and see which one of them goes through the point. Negative 1, 0.5 positive. So that would be like right here, and it doesn't look like this graph goes through that point, so this could be a possibility. Negative 1, 0.5 would be up here, so this line doesn't go through that point, so it can't be this one, so the correct answer here is C. You should also go through these 3 points and check to make sure these 3 are also on this line, but I'm pretty sure they are. So we're good there. Okay, question 19 says, again, which of the graphs represents this equation? So the equation says y equals 3/2 x minus 3. So this is an equation that's in slope-intercept form, which is y equals mx plus b, where m is the slope. So in this equation, the slope is 3/2, and that's a positive 3/2. So a positive slope needs to be going uphill. So just by inspection on these graphs, I can see this slope goes downhill. This cannot be a slope of positive 3/2. The slope is going the wrong direction. Also this one, the slope is going downhill. These lines are going off downhill. So these two graphs both have a negative slope, so neither one of them match this equation. These two graphs, B and D, both have positive slopes that go uphill. So it could be one of these. So let's look at B. In the equation, the B, which in this equation is negative 3, is the y-intercept, or the y-coordinate of the y-intercept. So this graph must cross the y-axis at negative 3. So I'm going to look at my two options, B or D, and see if this graph crosses the y-axis at negative 3, and this one does. So this is a possibility. When I look at this one, letter D though, and I go down to y negative 3, this line doesn't cross the y-axis at negative 3. The line is way over here. It crosses the y-axis actually at positive 3. But B is supposed to be negative 3, so it can't be this graph. So the correct answer here is B. It has the positive 3/2 slope, and it crosses the y-axis at -3. Alright, so we're going to move on to polynomials now. Simplify just means to get it down as small as you can, and in this case this is just a whole bunch of terms. So the only thing we really need to do to simplify these is combine like terms. I'm going to start with the highest exponent, which is 3. And I'm going to look at any terms that have an exponent of 3, and these would be like terms. So negative 1x cubed plus 6x cubed. You have negative 1 plus 6. Adding the coefficients gives you positive 5x cubed, and that takes care of these terms, so I'm going to cross them out. The next highest exponent is a square, or 2, so both of these terms have squares. So negative 6x squared and positive 4x squared make negative 2x squared, because you just add the coefficients, negative 6 and positive 4. And then we have the x terms, negative 3 and positive 8. When you add negative 3 and positive 8, you get positive 5x. And the last term is just a 5, and there's no other constant term to combine with it, so we just have positive 5 there. So that's the simplify, just combining like terms. Alright, we have another simplify here. This is a rational expression, just a fancy word for another fraction. We're just going to start with the coefficients, 4 over 2, and if you write them individually like this, you're just reducing this, either dividing it to be a whole number or reducing it as a proper fraction or improper fraction. So 4 divided by 2 does make 2, so when I put my fraction bar in, I know that this is going to be 2 on the top. It's a whole number 2. When I look at the x's, I have x to the 5th over x to the 4th, so that's like you're reducing 5 x's, 3, 4, 5, and on the bottom you have 4. When you reduce them, they cancel each other off like that, and you're left with just 1x on the top. If you know the shortcut, you're just subtracting the exponents. 5 minus 4 leaves you with 1x left over, so the exponent is 1, and there were more on the top, so that's where that 1 left over will be. Same thing with y's. When you use the subtraction rule, you can subtract 6 minus 2, that leaves you with 4 y's, y to the 4th, and there are more of them on top, so the y to the 4th goes up here. So actually, your fraction has nothing in the denominator, so you don't really need it. So this would be 2x, y to the 4th. Alright, we have more exponents here for simplify. When you have an exponent on the outside of parentheses like this is, that means that exponent has to go on every base inside the parentheses. And don't forget, your coefficient here, the negative 5, is not connected to the x. The negative 5 is its own base. So we're going to have a negative 5 with the exponent of 2 on it. The square is going to go on it. Then we're going to have an x to the 5th with an exponent of 2 on it. And we're going to have a y to the 6th with an exponent of 2 on it. So all I did was put that exponent 2 on the negative 5, the x to the 5th, and the y to the 6th, every base that was in this parentheses. And then I simplify them individually. So negative 5 squared means negative 5 times negative 5, which becomes positive 25. Negative times negative makes a positive. X to the 5th squared means x to the 5th times x to the 5th. Alright, when you multiply, exponents get added. But the shortcut when these exponents are stacked up like this is to actually multiply the exponents together. So either way that you think about this, it becomes x to the 10. And the same thing here. Y to the 6 squared becomes y to the 12. The shortcut here is to multiply the exponents. When you have exponents being raised to exponents, we multiply them.